Hi, I'm Shukla, creator and designer of ScaL, and this is ScaL, copyrighted to me, Shukla. ScaL is just not a calculator, it's an algebra system, graphing software, and numerical analysis software. This demo is obviously about ScaL, and it will show what ScaL can do. On a brief note, ScaL can do normal mathematical functions, sine, cos, tan, matrix manipulation, Fourier transform, interpolation, can solve ordinary differential equations. ScaL can do a lot more things than what that can be covered in this demo. Can handle symbolic mathematics. So let's start with basic operations like 2 to the power 8. Eighth root of 256, that's essentially 2. Binary number conversion, that is binary representation. Binary representation of -3. It has a drop down help also. And with function wise help. That's pretty much self-explanatory. So with 4, first bit is sign bit followed by number. In ScaL we can also create numbers, that is variables, and can do manipulation on them like base representation. Default is 2, padding is 0. Let's convert 32 into base 8, that is octal, with padding 1. We also have an inbuilt function octal that does essentially the same thing. There. Now can also handle hexadecimal numbers, that is base representation with base 16 hex. Now comes complex numbers. Right now we don't have any variable with a, but as soon as we create one, we have a variable a there. We can calculate conjugate. Can take real part, imaginary part, and can look into its absolute value. Now ScaL also have trigonometric functions. Let's clear this. ScaL also have basic trigonometric functions. radians. That will convert an angle given in degrees into radians. So what is 30 degree in radians? That's, we have sine, we have all functions like sine, cos, tan, hyperbolic sine, hyperbolic cos, and together with inverse functions, inverse trigonometric functions like inverse sine, hyperbolic inverse sine. So that's sine 30, and if we inverse it, these are the functions that are there. Let's stick to inverse of sine for now. Gives us angle in radian. There's one more thing. We have a sine, a special function sine. Sine dg, which takes angle in degrees and give us answer. So there it is. Similarly, we have tan and cos. Now so much so far for trigonometry. This is complex number. We have log, all sorts of log to the base e, log to the base 10, log to the base 2, log to the base e is also known as natural log. What we can do here is take natural log over a complex number, and we have something exponential that is essentially inverse of natural log. So if we take inverse of log of a, that will give us a back there. While to it, x can, as you already know, in ScaL we can create variables. What we can do more is we can manipulate variables. So that's x plus 2y, and we have binary shift operations also. So that's binary shift of x is left shift of y. Then as we can create variables and manipulate, we can use them to solve problems, mathematical problems like say compound interest problem. That's something like this, where principal is 1,500, rate of interest 4.3, rate of interest compounded quarterly, that is 4 times a year, and let's calculate for a duration of 6 years. So our amount is given by this formula, that is amounts to this much. After 6 years we will have amount of 1938.83 approximately. The ScaL can also handle very large numbers, large like to the power 2000. It's really a very large number.